Hello programmers, and welcome back to the Edulexis 90-Day Python Programming Masterclass. I am thrilled to welcome you to day 84. Up. Until now, we have built complex applications, manipulated files, queried databases, and handled advanced data structures. But today, we step into the mark of professional software development, unit testing. Writing code is only half the battle, ensuring that your code works consistently, handles unexpected user inputs, and doesn't break when you update future features is what separates a novice coder from a professional software engineer. Today, we will explore the Python built-in unit test framework from scratch, giving you deep insights into how automated tests safeguard your code base. Before writing a single line of testing code, let's understand the core philosophy. Imagine building a massive suspension bridge. Would you simply cross your fingers and hope it holds heavy traffic? Absolutely not. You calculate load strains, stress test the raw materials, and perform rigorous simulations before opening it to the public. In software engineering, unit testing serves that exact same purpose. When you write applications, manual testing manually, typing into inputs or running print statements becomes tedious, unreliable, and impossible to scale as your code base grows into thousands of lines. Automated unit testing allows you to isolate individual code components, called units, and check them automatically in milliseconds, guaranteeing absolute code health. Python provides a powerful, built-in library for this purpose called Unittest. You don't need to install any external packages using pip, it comes pre-installed with your standard Python installation. Inspired by Java's famous JUnit framework and XUnit architectures, Unittest provides an object-oriented approach to testing. It supplies its own test runner that automatically discovers tests, evaluates conditions, and outputs detailed diagnostic reports when something goes wrong. To leverage this framework, you simply import this unit tester module into your test script and structure your tests inside specialized classes that inherit from Unittest.TestCase, unlocking dozens of built-in validation helpers. Let's look at how a test script is structured mechanically. Suppose you have a simple helper function in your application that adds two numbers together, def add a, b return a plus b. To test this function, using Unittest, you must define a dedicated test class, for example, class test math operations, Unittest.TestCase. Inside this class, you write methods that perform the checks. Crucially, every single test method you write must start with the exact prefix test underscore. This is a mandatory convention in Python. The test runner scans your class specifically for methods beginning with the test underscore and completely ignores any helper methods that do not follow this rule. At the core of every test method are assertions. An assertion is an expression that evaluates whether a specific condition is true. If it evaluates to true, the test succeeds quietly, but if it evaluates to false, the test fails loudly with a descriptive traceback. The most fundamental assertion method you will use daily is self.assert equal a, b. This method checks whether your actual output matches your expected output. For instance, if you pass 2 and 3 into an addition function, you assert that the result equals 5. If the function returns 5, the test passes successfully. If it returns something else, Python flags an assertion error immediately. Beyond simple equality, the Unittest.TestCase class provides a rich ecosystem of specialized assertion tools. You can use self.assert true condition and self.assert false condition to verify Boolean states. If you are working with collections, self.assert in item container verifies that an element exists inside a list or dictionary. 2. Verify data types dynamically during runtime. You use self.assert is instance, object, class info. Furthermore, when your code encounters erroneous inputs, you can check if it raises exceptions. Properly using the self.assert raises exception type target_function. Arguments. These assertions allow you to test every edge case robustly. Let us trace a complete, practical example line by line. Imagine your script contains a function named multiply x, y, which returns x multiplied by y. In your test file, you import Unittest, define your test class inheriting from Unittest.TestCase, and create a method named test_multiply_positive_numbers. Inside this method, you write result equals multiply 4, 5, followed by self.assert equal result 20. When this method executes, Python computes the multiplication, compares the local variable result with the expected literal 20, and validates the operation. Building these small, atomic test blocks gives you absolute confidence when refactoring massive code bases later. How do we actually run these tests? At the very bottom of your test script, you include the standard boilerplate entry point if __name __equals __main _ unittest.main. When you execute your script directly from your terminal or command prompt, Python spins up its internal test runner. As the tests execute, you will notice a series of dots appearing on your screen. Each dot represents a successful test method. If a test fails, you will see an F accompanied by a detailed traceback, pinpointing the exact line number where the assertion failed. Seeing a clean row of dots across your terminal screen is one of the most satisfying experiences for any developer. Now that you understand the mechanics, let's explore an advanced industry methodology called test-driven development, commonly known as TDD. In traditional programming, you write the code first, and then write tests later or often skip them entirely. TDD completely flips this workflow on its head. You write your test case. Asterisk before asterisk you write the actual implementation code. Because the implementation function doesn't exist yet, running the test will inevitably fail. Once you see the failure, you write the absolute minimum amount of code required to make that test pass. This ensures your code remains clean, modular, and completely free of unnecessary features or over-engineering. As your application grows, tests often require repetitive preconditions, such as opening a database connection, populating temporary files, or initializing mock user sessions before every single test runs. Instead of writing duplicate setup code inside every method, Unittest provides special lifecycle hook methods, setup and teardown. That setup method automatically runs prior to every individual test method execution, while teardown runs immediately afterward to clean up resources, close connections, or delete temporary files. This guarantees a pristine, isolated environment for every test case, preventing cross-test contamination. A foundational rule in unit testing is strict isolation. A true unit test evaluates a single, discrete unit of code such as an independent function or class method completely isolated from external dependencies like real network servers, live databases, or local hard drives. If your test requires querying an active online server or reading live files, it is no longer a unit test, it has become an integration test. Maintaining strict isolation ensures that when a test fails, you instantly know the bug exists precisely within that isolated function, saving hours of painful debugging across complex application stacks. As beginners start writing tests, they often fall into common traps. One major mistake is writing tests that are overly complex. If your test script contains complex if-else statements, loops, or complex logic, your test code itself becomes buggy and requires testing. Keep Your tests completely straightforward, linear, and focused on verifying one exact outcome per method. Another common mistake is cramming multiple unrelated assertions into a single test method. If one assertion fails midway through, the rest of the method is skipped, masking other potential bugs. Always keep your test method small, atomic, and hyper-focused. While Python's built-in Unittest module is extremely robust, comprehensive, and universally available, professional Python developers often use a popular third-party testing framework called Pytest. While Unittest requires explicit class inheritance and verbose assertion methods like self.assert equal, Pytest allows you to write simple, plain Python functions using standard assert keywords. It also features an advanced fixture system and powerful third-party plugin extensions. While mastering unit tests gives you a solid foundation in object-oriented testing principles, exploring Pytest after today's lesson will open up modern workflows utilized across top tech companies worldwide. Let's discuss industry best practices to keep your test suites clean and maintainable. First, always name your test files with a clear prefix or suffix, such as test_math_utils.py. Second, give your test methods descriptive, self-documenting names that explain both the scenario being tested and the expected outcome. For example, test_calculate_discount_with_negative_price_raises_value_error. Avoid vague names like test_1 or test_function. Anyone reading your test suite should be able to read your method names and immediately understand the business logic, requirements, and expected behaviors of your entire application. To summarize our comprehensive journey today on day 84, unit testing is not an optional afterthought, it is an essential pillar of professional Python development. By leveraging Python's built-in Unittest framework, creating robust test classes, utilizing assertion methods, maintaining strict code isolation, and practicing test-driven development, you elevate your code quality to enterprise standards. Testing protects your code against accidental regressions, documents your design intent, and provides unmatched peace of mind as your projects scale. Thank you for joining today's session with Edulexis. Practice your unit tests, build clean test suites, and we will see you tomorrow on day 85 as we continue our advanced Python masterclass.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.